Welcome to Indices Part 5. Indices Part 5 is actually a continuation of Indices Part 4. So I would advise if you are coming across my video for the very first time, please do well to click on the subscription button and then try and go through Indices Part 1, 2, 3, 4 before coming over to Part 5 so that you understand it better. Because Part 5 is actually a continuation of Indices Part 4. All right, so under indices part 5, we have two examples. Simplify the square root of this plus the square root of this plus the square root of this. So we start with the first one. The square root of 160 r squared plus the square root of 71 r to power 4 plus the square root of 100 r to power 8. To solve a question like this, we first of all find the square root of 100 r raised to power 8. The square root of 100 is 10, and the square root of r raised to power 8 is r raised to power 4. Is r raised to power 4. How did I know that that's the answer? Square roots. From our knowledge of indices, that's why I'm saying you should go through part 1 before coming part 1, 2, 3, 4 before coming back to part 5. Laws of indices. If you have x raised to power 1 over n, it is simply the same thing as the end root of x, which means that the square root of 100 r raised to power 8 is the same thing as 100 r raised to power 8 raised to the power 1 over 2. As it. X raised to power 1 over n is the same thing as the end root of x. So this raised to power 1 over 2 is the same thing as the square root of this, which means that 100 can be written as 10 raised to power 2. R raised to power 8 can also be written like this, R raised to power R raised to power 4 and then power 2 again. Then everything raised to power 1 over 2. Look at it. R raised to power 4, 4 times 2 will give you R raised to power 8. Now, at this point, you can factor out the power 2. Still from our knowledge of indices, that if you have an expression like this, x, y raised to power n is the same thing as x to power n, y to power n. So which means that 10 raised to power 2, r raised to power 2, the power 2 can be taken out and you have 10 r to power 4. The power 2 is taken out, something of this nature. That x times y raised to power n is the same thing as x to power n, y to power n. So I can take the power 2 outside. It's the same thing as this expression. Then there is already power 1 over 2, which will now cancel this, and you have 10r raised to power 4. So which means that this expression is the same thing as 160r to power 2 plus the square root of 71r to power 4 plus 10r raised to power 4. That's the meaning. All right. So we can continue from there. And now looking at this, 71r raised to power 4, 10r raised to power 4, they are common. You can add it. And when you add that, you have the square root of 160r to power 2 plus the square root of 81r to power 4. 71r to power 4 plus 10r to power 4. That will give you 81r raised to power 4. All right, we'll still treat this one first. And the square root of The square root of 81 is 9. The square root of r raised to power 4 is r raised to power 2. So that will give us plus 9r raised to power 2. So this is now common. We can add it. And if you add, you have square root of 169r raised to power 2. And the square root of 169 is 18. The square root of r squared is r. And so that is the answer to that particular question. That's the answer to question number 1. So let's look at question number 2. Question 2 is saying find the value of the expression this x to power 3 minus this x to power 2 minus this x to power minus 3 when x is equal to minus 3 over 4. What that simply means is that you go to the expression. Let's look at number 2. You go to the expression. Wherever you see x in the expression, you put minus 3 over 4. That's the meaning. When x is equal to minus 3 over 4. So this will now become 32 over 81 times minus 3 over 4 raised to power 3 minus 64 over 27 times minus 3 over 4 raised to power 2 minus 81 over 16 times minus 3 over 4 raised to the power of minus 3. And so, let's continue from this other side. That will give us 32 over 81 times minus 3 raised to power 3 simply means minus 3 times minus 3 times minus 3, which will give us negative 27. And then 4 raised to power 3 is simply 4 times 4 times 4, 3 places. 4 times 4 times 4, 3 places, which will give us 64. And then minus 64 over 27 times minus 3 raised to power 2 is minus 3 times minus 3, which will give us 9 all over. 4 raised to power 2 is 16 minus 81 over 16 times, this is raised to a negative power. From our knowledge of indices, a number raised to a negative power is simply 1 over that number and the power becomes positive. So that expression will now be 1 over minus 3 over 4 and the power becomes positive. That's it. Okay. So from here, we'll see that 32 can cancel 1, cancel here 2. We can also see that 9 can go here 3 and 9 can go here 9. So we are left with minus 3 over 18. For this, we are left with minus 3 over 18. Over to this one. 9 can cancel here 1, 9 can cancel here 3. We can even use 16 direct or use 4 or even use 8. So if we are using 8, 8 here 2, 8 here 8. And so that will give us minus 8 over 6. Now, let's still look at this one. This one will now become minus, this is 81 over 16 times, this is the same thing as saying 1 divided by minus 3 over 4. When you change this to multiplication, it will now be 1 times 4 will go up and then minus 3 will come down. Take note, it is raised to power 3. So this will give us Reduce this, 3a1, 3a6. So we have minus 1 over 6, 2a4, 2a3, minus 4 over 3. And then looking at this one, that is minus 81 over 16 times 4 raised to power 3.
Yes.
Okay. I'm trying to see something. Ah, Benedism. Okay, Benedism.